Hello students, welcome back to the channel. As informed in the last video, today we will be discussing the very important product of vectors, the very important topic of product of vectors. Now, two vectors or the product of two vectors can either give rise to a scalar or can give rise to a vector. Based on this, we have defined, or vector product is defined or divided into two different categories. One is known as the scalar or the dot product. The other one is known as the vector or the cross product. We'll be starting with the dot product here. Why it is called the dot product? Because it is represented by a dot between the vectors. Let us say we have two vectors A and B here, and the angle between them, the smaller angle between them is theta. There are two angles between the vectors, right? One is the smaller angle, the acute angle, and the other one is the obtuse angle. We are talking about the angle between the vectors, the smaller angle between the vectors. So this is theta. Now, dot product or scalar product of A and B represented by a dot between the two. A dot B is defined as modulus of vector A, that is A, then modulus of vector B, and cosine of the angle theta between the two. So by definition, dot product of two vectors is simply the product of its magnitude of both the vectors and the cosine of the angle between them. Now, geometrically, let us see what it means. We have just discussed in the previous videos. If you haven't seen this, I'll put the link of my previous videos in the description. You can just refer to them. We have discussed about resolution of vectors, particularly the rectangular component of vectors, and we said that this is going to be very, very important in the future analysis or in physics. So let us say what it means. This particular expression, we can also write it as A into B cos theta. The same, putting a bracket between two scalars is not going to change anything. Now what is B cos theta? For that, let us go to this diagram. Now we know that vector B can be resolved in two mutually perpendicular directions. What we will choose is that one of the directions to be along vector A. So there will be a component of vector B along vector A, and then there will be a component of vector B along perpendicular to vector A. To find this, what we have to do, we have to draw a perpendicular from vector B to the direction of vector A, and this will be the component of B along A. And we drop a perpendicular from head of B to a direction or to the line perpendicular to vector A, and we'll get this length as the component of vector B perpendicular to A. Now this length we clearly know is from the diagram itself, since it's 90 degree. Using basic trigonometry, we can clearly find that this length is given by B cos theta. Let's call this B along x, or let's just say this length is B cos theta, this particular length. Why? Because this length divided by the length this, which is nothing but length B. This length divided by this will give us cos theta. So just the cross multiplication will give us this length as B cos theta. Similarly, this length will be B sin theta. Right? Now we can also do one thing. We can rewrite this equation as, since these are scalars here, B into A cos theta, which in other words means that the length of B multiplied by A cos theta. Now how do we find A cos theta? To do that, what we will do, we will have to resolve vector A along B and perpendicular to B. How do we achieve that? From A, head of A, we'll drop a perpendicular to B and this particular length, this will give us one component, and the other one is that we draw a line perpendicular to B and drop a perpendicular from A to this line, and this length will give us the other component. Now this component, if you look at this triangle, say let's call this O, this P, and this Q. Delta OPQ, since it's a right angle triangle, what we can find from here is very clear that this length, the given length, see, this is the base, this is going to be the hypotenuse now, this is the right angle, and this is the angle subtended by the base with the hypotenuse. So this length will be, this length divided by, that is OP, divided by OQ will give us cosine of theta in delta OPQ, right? Or OP is equal to OQ. What is OQ? OQ is vector A. So length of vector A into cos theta. In other words, this is A cos theta. So this is going to be A sin theta by similar analysis, and since this is a rectangle, OPQ say S is a rectangle, so we can say that this length is also A sin theta, opposite sides of a rectangle. So A cos theta, B into A cos theta means B into component of A along B. So dot product of two vectors are simply magnitude of one vector multiplied by the component of the other vector in the direction of the first vector. In this case, A, the magnitude of first vector, B cos theta is the component of vector B, the second vector, along the direction of vector A. In this case also the same thing, the first vector B here, and then A cos theta, that is this length, that is the component of A in the direction of B. Now this, since A dot B was A B cos theta, B dot A can be written as, B cos theta into A can be written as, B dot A. That is A dot B equals B dot A, which means dot product is commutative. We can easily show further that this is number one. These are properties of dot product. Okay, so the second property is that A dot B plus C is equal to A dot B plus A dot C. That is, dot product is associative. This is property number 2. Property number 3. Let us say vector A be perpendicular to vector B, which means angle theta is equal to 90 degree or pi by 2, say, which means that cos theta equal to 0, and so A dot B will be equal to 0. Clear? Now this is going to be very important. We will discuss it in a little while. Second is that number 4, if A is parallel to B, this will give us theta equal to 180, if parallel, then it has to be 0 degree or 0 is it, which means that A dot B is A into B into cos 0, that is 1, so this must be equal to simply the product of the magnitude of the two vectors. If A and B are antiparallel, that is, say if theta is equal to 180 degree or pi, then cos theta will be -1. So A dot B must be equal to A into B into cos pi or 180 degree, that is -1, which is equal to minus of A B. Fine. Now this property number 3 and 4 are going to give us some more interesting results. Keep this in mind. I'll just clear the board and then come back to you on this. So we say property number 4 was if A is parallel to B, then A dot B is simply A into B. Now, if I take the dot product of a vector with itself, that is A dot A, clearly these two vectors have to be parallel by definition because their magnitudes are equal. At the same time, they have to be in the same direction since both are vector A's. So we simply have A into A, that is A squared, which is nothing but modulus of vector A squared. Clear? Now, if we come back, remember the last video, we had defined or we have seen that I cap, J cap and K cap were the unit vectors along the direction of x-axis, y-axis and z-axis. So which it means that modulus of I cap is equal to modulus of J cap, that is magnitude, is equal to modulus of K cap. They are identically unity. Now if I use this property corollary to the property number 4, that A dot A is equal to A square, then I cap dot I cap must be equal to modulus of I cap whole square. However, modulus of I cap is 1, unity, we have just seen. So this is 1 square, that is 1. So the dot product of a unit vector with itself is 1. So if it is so, then it will also be the same for J and K. So I dot I cap is equal to J cap dot J cap is equal to K cap dot K cap. Fine. This was from property number 4. Also property number 3, if you remember, we have just discussed, says that if two vectors are perpendicular, A perpendicular to B will give us A dot B is equal to 0. Now we already have seen that I, J, K, these are the unit vectors along the 3 orthogonal axes, that is y-axis, x-axis and z-axis, x-axis, y-axis and z-axis respectively. So this was along, this is I cap, this is J cap and this is K cap, which are mutually perpendicular to each other, which means that if I take a product of I cap dot J cap, which will be given by modulus of I cap into modulus of J cap into cosine of theta. Theta is pi by 2 since they are mutually perpendicular. This must be equal to 0. And so I cap dot J cap is equal to J cap dot K cap is equal to K cap dot I cap. All three are identically 0. So dot product of two unit vectors along two different axes is always going to be 0. Fine. Clear till now? Okay, now let's move on to the next property. We have also seen that any vector A can be expressed in 3 dimensions in terms of its 3 components, like Ax cap, or say in terms of the unit vector, its magnitude along x-axis into I cap plus Ay j cap plus Az k cap. You may please refer to my previous video to clarify this if you have any doubt. Similarly, another vector B can be given as Bx I cap plus By j cap plus Bz k cap, which means that if I take the dot product A dot B, we simply take the dot product of this with this, right? Ax I cap plus Ay j cap plus Az k cap, and Bx I cap, By j cap and Bz k cap. Now to take this product, we will make use of the second property, that is dot product is associative. So if I take a dot product between this and this, so we can open this up and say that this dot product is equivalent to Ax I cap into Bx I cap plus By j cap plus Bz k cap plus Ay j cap into the same term plus A j k cap, the same term, right? So if I take this product first, there will be a dot here, there will be a dot here, and there will be a dot here, since we are taking dot product of the two, A dot B. So Ax and Bx are coefficients or constants, so we take this outside. Ax Bx I cap dot I cap. So I cap dot I cap we have just found is 1. So we are left with this first term plus Ax By I cap dot j cap, which is 0. So we have substituted 0 and Ax Bz into 0, since I cap dot k cap is 0. So from the first term of the product, we are left with only one term, that is Ax plus Bx. If we use a similar analysis or take the entire product, what we will see, we will be left with Ay By from the second term and Az Bz from the third term. Fine. Now let's go back to the first equation. A dot B equal to modulus of A modulus of B into cos theta. Cross multiplication will give us cos theta equals to A dot B by modulus of A into modulus of B. Now we have already seen A dot B is given by this equation. We don't have a problem with that. So we need to find how to find modulus of A. Now to do that, let's get back to the property that correlate to the property that A dot A is, if I take product of A with A, that is this vector is A and this is also A. So Ax instead of ax into bx, we will be left with ax into ax, that is ax squared. Similarly, ay into by will be ay squared, and the third term will be az squared. But a dot a is a squared, or a squared, or modulus of a whole squared. That is, a vector, modulus of vector a will be given by square root of ax squared plus ay squared plus az squared. Similarly, modulus of vector b will be given by bx squared, by squared plus bz squared, whole thing under square root. So cosine of theta will be given by a dot b will be ax bx plus ay by plus az bz, whole thing divided by two square root terms, ax squared plus ay squared plus az squared, whole thing under root, and multiplied by another square root term, bx squared plus by squared plus bz squared. Alright. Now, in the next video, we will discuss the other product of vectors, that is the vector or cross product. That will be our topic for the next video. Thank you for watching, and if you like the video, please do press the like button and also subscribe to the video so that you do not miss any of my updates. Thank you.